Welcome everyone. Thank you a lot for being here today. I have a session where I would like to talk about dynamic policy enforcement for privacy techniques in gRPC. Privacy is generally not the subject most engineers, most software engineers would like to focus on, and I have the same view. The way I look at it is that it is an extension of security engineering. We're introducing another layer of security, as typically we always try to have layered security to get the principle of least privilege applied. And privacy can be seen as yet another layer that we can apply to secure data, to have more control over the data that we exchange. And gRPC is very interesting for this subject, as gRPC is at the root of data exchange and data transaction. So let's get going and talk a bit about what we're going to cover today in this session. We all know that gRPC is widely used in microservices, high-performance operations, and there's a lot of implementations out there in industry. But when it comes to legislation, there's a lot more push nowadays, both in Europe, in the US, probably many other countries as well. Typically, I do come from Europe, so I have more insight into GDPR. The CCPA is not really something I know too much about, but I have read into it, and I see there are similarities between the two. The GDPR itself looks a lot more at user rights, what data they should have control over, they have the right to delete it, and the CCPA has kind of like similar rights that they give to consumers. They are able to request a deletion of the data, they should be informed of what happens with that data, and adhering to not keeping to that can result in some hefty fines. And we'll not focus too much on the legislation here. We're going to look a bit at code today, see what gRPC can do and how we can do that actually. So one main reason that we're trying to look at privacy engineering with gRPC is the lack of advanced privacy techniques that gRPC has. So gRPC has transport security encryption. There's a level of token-based authentication, but it is not very straightforward to implement privacy engineering techniques into it. And those techniques are specifically data minimization and purpose limitation. And we'll dive a bit deeper into that. Go to the next slide. A little bit about myself. I'm Rami Haddad from Amsterdam, the Netherlands. I work for Cisco Outshift. And Outshift is a department in Cisco which tries to focus on markets that the company typically does not work into. For example, software that is security on the software side. I personally worked on the cloud security space, and I did a bit of research on API security, and lately a bit into gRPC, specifically with privacy engineering though. Okay, so let's take a quick look at privacy and gRPC. We know that data of consumers is typically held at our data centers or cloud environments, but it is not our data, it is third-party assets that we're trying to manage and distribute for our services to make use of. And the reason that is important is because this data does not belong to us as companies that we process that user data. So there's a real emphasized need that we need robust data protection principles in there. We bind this back to GDPR and the CCPA in the form that the GDPR states it's a fundamental right for users to protect that data. The CCPA rephrases that in a different manner. It is less about the protection of the data, but much more about the consumers having a form of right on the data. So they can request the deletion of it. They can know what other businesses are having access to it or whether that data is actually being sold. And the reason this is becoming very important is we're starting to see it in Europe a lot more, where the CGEU, which is the European Court, is starting to introduce even more measures called the Data Act, AI Act as well. And they're looking at how they can actually measure the level of privacy. So in addition to introducing fines if that is being violated, they're actually trying to look at in what level they can measure how automated the process is of decision making for how data is shared. So when data is shared, how do you know whether the user actually needed that data? And we spoke of purpose limitation and data minimization. And those two core principles of privacy engineering, they can be traced back to the GDPR itself and the CCPA to an extent as well. Now, in addition to that, those are two very important reasons, of course, the legislative requirements. But there's also a very very often in the news we read about breaches, data loss, and this can have very negative effect on a company's reputation. We can go on back. We can see that here in one post on the X platform where it has been shown that many records, millions, sometimes billions even of records have been made public. And this does not only hurt the company's reputation, but it can result in fines, which is more and more often happening these days. So the consumers are becoming a lot more careful with whom they want to share their data. And some research has shown that they feel most safe to share their data with the financing sector and the healthcare sector out there, due to being, they have a lot more compliance that they need to keep in line with, of course. So to jump towards the legislative part, we spoke of what the CGEU is trying to introduce, the Data Act, the AI Act, of course. But to be more specific, data minimization and purpose limitation, whilst it is mentioned in the GDPR document and CCPA, implementing it manually, which is what currently has been happening, is very unproductive. It's quite difficult to get that done. And it is often not applied at the gRPC level, which is something I think is very practical to implement to, and it's also very effective given that it's at the root level of data exchange between microservices. So let's look a bit deeper into why gRPC. Why would we like to do this with gRPC? So we mentioned the lack of native support. gRPC is at the root of the data exchange. Currently, it is such measures, if implemented in the technology itself, developers tend to do it in an ad hoc fashion. So they create their own mechanism to implement it. And this can work, but it is also very prone to error. You would much rather have a declarative style of privacy description where a user has a framework ready and they can make use of an existing framework to, in gRPC, set certain rules that perform data minimization and purpose limitation in this case. So let's take a look at, so the end goal, we could call it privacy by design, but that's kind of taking it from the security by design approach. And the end goal is that it becomes another layer on top of the security layers, and you can fulfill both the security and privacy separately. And that is, for example, if PII data, personally identifiable information, is released unintentionally, if we apply data minimization and purpose limitation, that data might not have enough context to be relevant. So the security of data is another topic. We're really trying to minimize the amount of data that is exchanged for even further security. So we can touch very quickly on those two, but we mentioned them already. We much rather look at how do we actually enable purpose limitation. And the method to do that is that by every part of data, every category of data. So we would like to categorize data, and each category will be binded to specific purposes. And we'll show some code examples of that. The reason that we do that is once data is binded to specific purposes, we can enforce that purpose limitation, but we can also have further measures, which is data minimization. And it makes a lot more sense to show some examples here, of course, but some requirements that are very important to achieve this, because we would not want any downsides, any cons to an approach like this. Configurability, of course, and we want to limit the performance overhead that we have with this. There is overhead, though, because there have been some implementations, and there is definitely more latency in the data exchange, which is a very big deal for gRPC. It's very relevant. So that is not, there's much more need for work on it before it actually gets into production in this form of implementation. And dynamic allocation, of course, on the go. That's the whole point of automating privacy engineering here. And there are a couple of techniques we're going to show. And those techniques, they differ a lot. Some are much more intense than the other. If we look at generalization data blurring, an example can be a year of birth, date of birth, for example, data. Instead of supplying that specific data, you can generalize it in the form of age ranges, for example. And it really depends on the use case. In some applications that matters a lot, that is not doable. But sometimes you can do it, and you can still provide the relevant information for the specific operation that you have, especially for statistical analysis applications. This would still work out. Then there is noising as well, which is adding controlled randomness. So you add some data, you replace certain data in the application. And with that, you can still make some form of context out of it. But if you bind it to a user's identity, you do not gain further insight into their PII. So then there is a much more severe form, which is kind of suppression. Suppression is really you take that data out, you don't provide it at all. And it, again, depends on the case. In the application, the way we try to apply it is that we have a switch statement, and that's a very simple form of how we would apply it. And we'll get to showing that. Then finally, there's reduction, which is kind of truncating information. So you have a postal code, maybe. You can show the first two bits of that data. And currently, this is already being applied in various sectors, to an extent at least. For example, if you log into a data exchange broker, you might see only a certain part of the value of the financial balance that you have, or maybe the postal code, or things. They try to anonymize data. And that is usually on the viewing side, on the user interface side, rather than the exchange. But we can get to that further. Okay, then there's purpose limitation, which follows a lot of the security engineering side, principle of least privilege that we try to apply, policy guardrails. And eventually what we want to get to is contextual data handling, which means that all data has various angles, various sides to it, and specific operations have very specific purposes. So we can have, there's no one side, there's a unique view to each request that we can guarantee or give to the user. Okay, so let's take a little bit deep. We spoke of this, that we would like to introduce a security layer known as privacy security. The goal is purpose-based access control, which is very synonymous with context-based privacy. And we kind of looked at this by looking at the extended access control markup language architecture, which consists out of 3 components, which is the policy administration point, policy enforcement point, and policy decision point. And these 3 areas, we looked at implementing it in gRPC as well, using an interceptor, using gRPC middleware. And it is a very simple implementation in this case. We tried to minimize the middleware in there because that's just another layer between gRPC operations. And the idea is that if a gRPC request is made by the client to a server, the client would have to create a JWT claim, and that claim contains what data they would like to have and for what purpose. And the middleware would be sitting in between. The middleware then looks at that request, validates the JWT, and minimizes and performs purpose limitation on that data before returning it. And that goes in various steps. And we can run through that in the code instead, given the time that we're having. Let's take a look at it. And the idea is really that the interceptor becomes the privacy control point here. And this is an extremely simple example where the transaction customer ID is anonymized. This is data minimization. This does not yet perform any purpose limitation. I would rather show it in code. Let's head to a piece of code here. Hold on. There we go. Okay, so what we have here is a very simple example. We have the client that provides a field, which is the claims. And in the claims, the client really shows what they're trying to do, what they're trying to achieve, and what data they are requesting. What we then do is, in the middleware, in the interceptor that is, we validate the JWT, we validate what the client is requesting, we parse it, and we check the purpose of the request here. And in this case, this is about an order, so it's an ordering service. So a customer can order, and then there's billing, there's shipping, and there is, of course, user data involved, address, name, etc. But for shipping, for example, you do not necessarily need the data of the billing address. And therefore, we apply data minimization here. We remove the sensitive fields that are not needing by the shipping service. We also do apply data masking in case of the postal code for the delivery person, that is. They do not need the full delivery postal code. You can minimize that so that they can still have the relevant information needed to fulfill their objective in this case. And we also can provide data anonymization. It really depends on the operation. And in this case, we showcase the operation per case, which is a very simple form of trying to implement this. There's shipping and billing. In billing, what we try to do is we remove the information of the customer. We don't show the shipping address. We do show the information of the customer, but the shipping address in this case is not necessary. Now, this is not very critical. Even if we show this data, it does not really matter that much usually. But in some critical operations, in critical infrastructure, it might have a much more effect in the financial services, for example. And there it might mean a big difference between being compliant or not, being at risk if PII data is exposed, whether it has enough context to cause any damage, reputational damage, or certain other damage. Let's head back to the slides here. All right. So a kind of a sequence of how this would work is what we just showcased, where the client itself, when they initiate the request, a JWT token is utilized. The interceptor then gets to work to validate that, performs a contextual check, starts applying that privacy policy, which involves also data transformation. The data that they receive is no longer the actual full amount of data. We do some work in there, modified response. And the way that we achieve this is utilizing these three components down there: the policy decision point, administration point, and enforcement point. What we just showed you, the piece of code, would be the enforcement point in this case, a gRPC interceptor, which has to be really lightweight to not cause any delay. But the PDP and the PAP, administration point, they typically have the authorization policies that would have to be predefined. The decision point is really the authorization engine, which then compares what the interceptor gets and tries to perform the access control. And from there, the data transformation modified response is performed. And there has been various work on this as well. The link that I've put down there below has a team in Germany that they have also tested this approach. They looked at gRPC interceptors for privacy engineering. They did find that there is quite some impact on performance, though. Still reasonable, because in the GDPR it is also stated that it has to be to a reasonable amount, the delay and the cost of implementation. But that level, whether it is reasonable or not, depends really on the service, of course, on the implementation, on the application that we have. And the end goal is really to, of course, if we can not introduce too much delay or overhead, introduce privacy by design into gRPC, especially given that it's at the root of data exchange. If we can introduce declarative privacy by simplifying it so that development teams no longer have to come up with their own implementation, we can safeguard against errors in this case. And we make we introduce the concept of the interceptor as also a dynamic privacy gatekeeper that can be used easily. There are, of course, next steps involved. There's a lot of work into privacy engineering in general, and I have not focused too much on these concepts. This is much more about gRPC and how we could introduce that layer into it. There are various deep methods that are very rigorous, like differential privacy and k-anonymity, which take privacy a step further into this field. And to really sum that up, that k-anonymity is, for example, if you have specific user data, if you produce a release of that same data, that does not allow anyone to identify the actual person or group behind that data. And that can go into a field of formal verification as well, where you try to prove that mathematically, but whether you need that or not, that is really another talk. For now, I hope you had some insight from this. There's a lot more to progress in this before it actually becomes relevant, or before I can show a actual proper demo that can be seen in runtime or in production environments. But thanks a lot. If you have any questions, I would feel free to ask them, or otherwise, thanks a lot for being here today, of course.
Quick question for you. So
Sure.
you mentioned that you're using a JWT token to kind of state the client's intention with the data, right? So in other words, you can get the scope from the grant and then say, okay, based on this. In gRPC, those are usually given once when an RPC is established. So the idea is that when a client starts talking to an RPC, that's the only time that the authorization is going to be enforced, right? The data implementation would be at the RPC layer, correct? So in other words, if the client wants to change using the data, the recommendation would be for them to, they would almost have to close and reopen the RPC in order for your updated policies to take effect. Does that make sense?
Do you mean that it's not on the go? Like, of course, it's a stateful connection, so it is not.
So it's a stateful connection, but let's say I'm client A, and one time I get your data, I'm pulling back data, and you minimize it, but then the next time maybe I have a different intention with the data that I want to use. Like maybe they upstream it. Maybe
Got it. Yeah.
or the client sending the data back.
Yeah, the idea is really to have it on the per request, really per request, and the way it would be is that in the same diagram here.
So are you talking about customizing gRPC then? Because the JWTs go for call credentials.
Not changing gRPC. It's more about just the introduction of the interceptor as a concept.
Which fires off once per call.
Yeah, once per call. Once per call. But of course, it is stateful, right? So the like we typically try to have stateful implementation, so that might not be very easy to have
just confirming, that's the idea.
Yeah.
I like what you're saying. So.
Yeah. It also depends on the per implementation, of course. This is just one method.
Tough challenge to solve.
It can be so many. Yeah. Anyone else with some questions? No? Then thanks a lot for being here today. Appreciate your time, and looking forward to get to know you. Thanks, sir.
Thanks for sharing.
Thank you.